This is question 10. Refer to this diagram. AD is perpendicular to BC, while PQ is parallel to BC, given that PQR is an equilateral triangle, and the area of PQR is equal to AD. If so, what is the shortest possible value for the length BC? Let PQ to be A. If PQ is equal to A, then the area of triangle PQR will be equal to half AB sine C. Sine 60 degrees is square root 3 over 2, so this will be square root 3 over 4 A squared. This is the value for the area of triangle PQR, and it's given that is equal to AD. Equals to AD. Let the intersection of AD and PQ be the point D prime. So we see that DD prime is actually the height of the triangle PQR. So the area of triangle PQR also can be written as half of the base, that is A, and the height is D prime. And this is the area of triangle PQR, which is equal to square root 3 over 4 A squared. This implies that DD prime is equal to square root 3 over 2A. And therefore, AD prime is equal to square root 3 over 4A squared minus square root 3 over 2A. That is square root 3 over 4A, A minus 2. Next, we note that the triangle APQ is similar to the triangle ABC. So maybe I write here. And the height is D prime, AD prime, and the height here is AD. If this so, then the corresponding side or even height is of the fixed ratio. It means that BC over PQ is equal to AD over AD prime. We know what is AD, we know what is AD prime, we know what is PQ, then we are able to find out what is BC. So this means that BC is equal to AD over AD prime times PQ. AD is equal to square root 3 over 4 A squared. AD prime is square root 3 over 4A, A minus 2. PQ is equal to A. We cancel off A and A, square root 4 and square root 4. Then this is A squared over A minus 2. Now, we rewrite BC in terms of A. In order to get the minimum value for BC, we can use calculus. But right now, we try to use some other technique, that is AMGM inequality. BC is A squared over A minus 2. A squared can be written as A minus 4 plus 4. So A squared minus 4 is A plus 2, A minus 2. A minus 2 cancel off. Then we have only A plus 2 plus 4 over A minus 2. In order to do the AMGM inequality, I need to have A minus 2 plus 2 plus 2 plus 4 over A minus 2. That's the reason why I need to write as 2 plus 2 instead of writing a 4. So let's recall what is AMGM inequality in the next slide. So using AMGM inequality, this will be greater or equal to 4 of everything multiplied together, then to the power of 1 over 4. When you take the product of these 4 terms, A minus 2 will be cancelled off, and you're left with 2, 2, and 4. 2, 2, and 4, this is 16. 16 to the power of 1 over 4 is 2. 4 times 2 is equal to 8. So BC is greater than or equal to 8. But we need to check whether equality holds. Can BC actually equal to 8? If that's the case, each of the terms has to be the same. If each of them has to be the same, it must be equal to 2. So 2 plus 2 plus 2 plus 2 equals to 8. Now, this can be equal to 2 if A equals to 4. 4 minus 2 is 2. 4 minus 2 is 2. 4 over 2 is 2. So when A equals to 4, this value is equal to 8. So this 8 is achievable. And right now, we can sure to say that the minimum value for BC is equal to 8. And therefore, 8 is the answer for question 10.